Hi, welcome back. In this video, we're going to learn about lists. Lists are nothing but a way to store a collection of values. Very often in programming, you will not work with individual values, you will work with a collection of values. And list gives you a perfect way to store all the values together and manipulate and work with them in different ways. We're going to see some examples of it. Let's switch to the terminal. So go into the Python shell. I'm already in the shell. To create a new list, let's say we want to store a list of scores. We can say scores equals, you will use square brackets, which means you're telling Python you are creating a list. And let's say we want to store 30, 40, 50, and then 60. So I want to store a list of scores. I have 4 scores and I want to create a list of it. Press enter and that's it. You have created a list scores. We can display it by just typing scores and Python will display it for us. Now keep in mind that lists are ordered. So each value that you have has a position. So remember when we learned strings, we talked about index. Index is nothing but a position. Here, list also uses index. So index 0 is 30, index 1 is 40, index 2 is 50, and index 3 is 60. Again, remember that indices always start at 0 in most programming languages, and sure enough for Python as well. So if we do scores square bracket 0, you will get 30. So by doing scores square bracket 0, we're asking Python, hey, give me the value stored in index 0, which is 30. Now you can find the length of a list using the same function that you used for a string, which is len, short for length. And we can say scores gives you 4 because there are 4 values stored. There are several other built-in functions that you can use. Let's say I want to add another value to the end. Let's say I want to add 70 to the list. I will do list.append 70. Oh, sorry, it should be scores.append 70. Sorry about that. Now no error. So if I display scores now, it has 70 added. Again, I can do a len on it. It will give you 5. And then you can do remove as well. So we appended a value. Now we can remove a value. So we can do scores dot remove. Let's say I want to remove 50 from it. So I'll do remove 50. And then I'm going to display scores now. Now 50 is gone. So we're now back to 4 values. 70 is still there, but 50 got removed. Now, what if I want to remove the last item on the list? So I don't want to say 70, but I want 70 gone. There is another method for it called pop. So if I do pop, I don't have to specify a value. So 70 is removed, but see that 70 got displayed. There is a difference between a remove and a pop. Remove basically removes the value that you specify. So we specified 50 and 50 is gone. Now pop also removes a value, but it works a little bit differently. It removes the last item. You don't have to specify the item or value. It just removes the last value, but it also gives that value back. If I display scores, now 70 is gone. So 70 got removed, but the pop function also returns. So if I want to say last score equals scores dot pop, now it did not display the last value, which is 60, but 60 got removed because if I do scores again, 60 is gone. Now if I display last score, 60 is scored there. Saved there. So So that's the difference between remove and pop. Pop basically removes the last value but also returns the value, so you can assign it to another variable and then use it. Let's see what scores has two values. Let's append a couple more. Let's do append 45 scores dot append 55, and then scores dot append 65. Display scores, we should have 5 values. Now let's look at another function. It's called reverse, and as the name says, it is going to reverse the list. So remember I said lists are ordered from 0th index to a particular index. So when you call reverse and then display, now it goes from 65 to 30. So now if I do scores of 0, I get 65 because the list itself is reversed. So the order got reversed. Now 0 points to 65. Index 0 does not point to 30 anymore. And we looked at pop, which removes the last item. Now for pop, you can also supply a position. So if I do scores.pop, it's going to remove 30, right? So now 30 is gone. Now what if I want to remove 55? I can do scores.pop of 1. Remember, position starts at 0 or index starts at 0, 0 and 1. So 55 is 1. Now 55 is gone. There you go. So pop by default removes the last item, but you could supply an index and it will remove that particular value or item corresponding to that index. And the final function I want to show is a copy. So again, let's display scores just to see what's there. So we have 65, 45, and 40. What if I want to copy the list into another variable? I cannot do scores2 equals scores. Although it works, both scores2 and scores are pointing to the same list. I'll show you how. It has these values. Scores has the same values. Let's say I am appending something to scores. So I'm adding 85. So now if I display scores, I get 65, 45, 40, and 85. Let's see what scores2 has. It has the same values. So although they are two different variables, they are pointing to the same list. This is what we call reference. So scores and scores2 are pointing to the same list in memory. So it's referencing the same. So this is not a true copy. So by just doing scores2 equals scores, we did not accomplish copying. To copy a list, which is to create a different list, a copy of the list, and have a variable point to that new list, you will do something like scores2, or let's do scores3 so we don't confuse ourselves, equals scores dot copy. Now let's display scores3. Now let's display scores. So we did a copy. We're displaying scores3, which has these values. We're displaying scores, which has the same set of values. But since we did a copy, they are two different lists. Now we can prove that by appending again to scores. Now this time I'm going to append 100. I'm going to display scores again, which will have the 100. But if I display scores3, which is the one that we created by copying, it does not have the 100. So please note the difference between this example that I showed here and this example. Here we made a true copy, which is why when we update the original list, the new list does not get affected because they are two different lists. Whereas here, we just did an assignment. So we assigned by reference. So both of these variables are pointing to the same list, which is why when we updated scores with the new value, scores 2 also got updated. So that's the final example I wanted to show. As I always say, there are several built-in methods for many of these, just like strings. Even lists have many built-in methods. I would highly encourage you to look at Python documentation to find what other built-in functions are available and practice the ones I showed as well as the new ones that you see there. Because when you're programming, when you have a need to work with the list in a particular way, either knowing there is a built-in function available to do it, or looking up documentation to find out which function would help you do what you're thinking of doing, is something you would normally always do. So practice always helps. Please practice these functions and the new ones that you see in the documentation. Thanks for watching.